All right, now let's see what happens when you have resonance in undetermined coefficients. And so let's now guess the form of a particular solution to x prime equals ax plus f, where A is the matrix 1, 1, 4, 1, which is the same matrix as the previous video. And once again, before I even tell you anything, find the eigenvalues, because here they're important. So once again, you can check the notes for that. So the eigenvalues are -1 and 3. And this time, assume the right-hand side so f of t is e to the 3t and then 2e to the 3t, which if you want is e to the 3t 1, 2. So here what happens, the right-hand side has e to the 3t, which corresponds to lambda equals 3, which this time it coincides. So in fact, there is resonance. And the question, what do we do here? Once again, it's by analogy. So before, if we had resonance, we had to add an extra t, right? We would guess something like yp is at e to the 3t. Now, it turns out for systems, it's not quite correct. So the correct guess here would not be at e to the 3t, but at plus b e to the 3t. You can try it out. If you just do at e to the 3t, you wouldn't be able to solve for it. You really need at plus b. And so here, what we have, xp of t would be ab t plus cd e to the 3t. And you just do this trick on the term that has resonance. So if you had an extra e to the 2t, you would just deal with it as usual. Okay, so in fact, let's practice with that a little bit. So let's now do f of t. Let's do e to the same thing. So e to the 3t times 1, 2. But now let's add a e to the 4t times 2, 7. Once again, here the right-hand side has e to the 3t and e to the 4t. So for e to the 3t, we do have resonance, corresponds to one of the eigenvalues. But e to the 4t, we have no resonance. And so the correct guess would be xp of t is, again, abt plus cd e to the 3t. And then for e to the 4t, you just guess the usual thing. So ef e to the 4t. Right? Because for e to the 3t, you have resonance, but for e to the 4t, you don't. Okay, moving on. So let's now do a couple of complex things. So A is a matrix. It's a different matrix with eigenvalues. So lambda is 3 plus minus I, and in this case, f of t is e to the 3t cosine of t and 2e to the 3t sine of t. Well, in this case, well, the right-hand side has e to the 3t cosine of t, which does correspond to lambda is 3 plus minus I, which coincides. Sides. And then there is resonance. Okay, so what did we do here? So again, by analogy, we usually would guess AT, with one, again, the correct term, not AT, but AT plus B, e to the 3t cosine of t, and plus CT plus D, e to the 3t sine of t, except we have vectors. So here xp of t is ABT plus CD e to the 3t cosine of t plus EFT plus GH e to the 3t sine of t. So once again, resonance, except instead of doing AT, you guess AT plus B. And now let's just combine everything. So two more examples. So the same matrix, the one with eigenvalues, lambda equals 3 plus minus I. But in this case, your F term is 3t, e to the 3t cosine of t, and then 2t plus 4, e to the 3t sine of t. So same thing. So we have resonance, which usually gives you AT plus B. But also here we have polynomials, which are degree 1, and so you have something of degree 1. So this 3t and 2t plus 4, that would become another AT plus B. And if you multiply this, you get something quadratic. So the product is degree 1, 2. So once again, I know it's a bit complicated. You have a linear term because of resonance, but another linear term because of those polynomials. So in the end, you get something quadratic. So the true analog would now be AT squared plus BT plus C e to the 3t cosine of t plus dt squared plus et plus f e to the 3t sine of t. Except we need to write this in terms of vectors. So what we end up getting is xp of t is, in this case, AB t squared plus CD t plus EF e to the 3t cosine of t, and then plus GH t squared plus IJT plus KL L e to the 3t sine of t. And the last thing I want to mention is just repeated eigenvalues, which again, rare, but it could happen. So A is a matrix with repeated eigenvalue. eigenvalue. Lambda equals 2. And f of t is e to the 2t, e to the 2t, which is e to the 2t times 1, 1. So here, the right-hand side is e to the 2t, which corresponds to lambda equals 2, which coincides with the repeated eigenvalue, lambda equals 2. So in fact, there is not just simple resonance, but double resonance. Resonance. Again, double trouble. And again, the analogy before we had at squared e to the 2t, but now the correct analogy would be a quadratic term. So at squared plus bt plus c, e to the 2t. And in that case, you would guess xp of t is, again, vectors. So ab t squared plus cd t plus ef e to the 2t. Whew. And that is all you need to know for undetermined coefficients for systems. Whew.